In this tutorial, we will look at IPKIS Canvas, which is your design co-pilot that works alongside the other Lucida tools to enable a comprehensive photonic design flow. It can be used as a schematic capture tool and assist with creating new circuits. A schematic at a basic level is a visual representation of a circuit in which components and subcircuits are simplified into single blocks, and the top-level circuit represents the connections between these blocks. It is not a physical layout with structures, waveguides, and dimensions, but rather an abstracted view that focuses on logical connections and uses icons to represent components and subcircuits. You can open Canvas directly from the Lucida Control Center or by calling to Canvas on a layout view of a P-cell or circuit. When you first open Canvas, a guided tour will show you around. Here we see the Canvas interface, where you have a library menu on the left-hand side which can be expanded, and on the right you see the schematic showing all of your circuit instances. We can interact with the schematic by right-clicking on an instance and bringing up a list of useful options. For example, the properties of that instance. The Properties pane opens up on the right-hand side and contains lots of information about that instance. And if you scroll to the bottom, you will also find metadata, which you can also edit and customize. You can also view the parameters in the schematic by clicking Show Card, and it will display a resizable card. This card shows all of the parameters that are not hidden in the Properties pane. To create a schematic, you simply drag and drop components from the libraries into the workspace, and it's a very easy matter to connect them together. Just click on two ports, and that will create a connection. You can also rename instances and edit their properties by clicking on an instance, then pressing P. Canvas also allows for easy alignment of multiple instances. You simply click on multiple instances and select the method of alignment. We can also add external terms. We simply right-click anywhere on Canvas and select the type of term we need, either electrical or optical. A really powerful feature of Canvas is the code template possibility. You can generate code from the schematic using our code templates. Once you've implemented a schematic you're happy with, you simply right-click anywhere on Canvas and select Code Templates. You can then choose between different code templates. It will generate a full code of your schematic. Of course, this code will not be completely optimized, but it's a great way to get started. You simply copy and paste it into your code editor, and then you can proceed from there. So let's look at an example. So we open Canvas and start a new project. We'll give the project a name. Here it will be Demo. And we select a project path. Here I put it inside the Canvas folder in the IPKIS PyCharm environment. Next, we select a PDK. So I'm going to use the SciFab demonstration PDK that comes with your IPKIS installation. And now we will create our canvas. So to the left-hand side, we see our library of components. So we go down into the SciFab PDK and we will select the components we need to build the splitter tree. So we select an input grating coupler and 4 as outputs. And we'll drag and drop 3 MMIs. And now we can look at some of Canvas's features. So let's look at aligning. So we select the 4 output grating couplers, select align and to the right. And now they are neatly positioned. And we can do the same for the MMIs. For the input grating coupler in the first MMI, we can choose to align it from the top of the device. So we right-click on the current device and we select Properties. And we can see its current positioning in X and Y and its angle of rotation. We can also flip the output grating couplers. So we simply select Mirror X and now the ports are switched. We can also right-click on a device and select Show Card. If there are any parameters that are configurable, they will be visible here. To connect the devices, we simply select a port and then click on the port we would like to connect it to. Next, we can select our external terms. So we right-click on Canvas and select Optical or Electrical External Term. Now we have our schematic as we want it. So now we can export it to code. So we right-click on Canvas and we can select a code template. Here we're going to use the Connect Manhattan Connect Electrical template. And finally, we can copy and paste this into our code editor. So we'll open up the PyCharm environment and the Canvas section, and I'll create a new Python file called demo.py. So now we can copy and paste the generated code. This code is far from optimized. So what you would do next is try to improve it, and then you can re-export it to Canvas to visualize it. So let's look at what we can do with this code and make a few changes. We will start by making it more parametric. So what we will do is define the spacing in X and the spacing in Y as parameters. And we will set these with the i3.positiveNumber property because it will be a positive number. We will also make a parameter out of our grating coupler and the splitter. Next, we will define the splitter as a default object. As well as the grating coupler. Now we will make a dictionary of our instances, in which will include our MMIs as splitters, and our grating coupler. We can use a for loop for the grating number. Inside the loop, we will use an f string. So the grating number variable is inserted into the string to create keys, for example, gcout0, gcout1, etc. Now we can clean up this return statement. We can delete all of these entries and simply replace it with insts. There are different ways to optimize this further, so let's look at a slightly more complete example. Here we see what we've previously done with the default components and the inst dictionary. We can also adapt the specifications by making a list, and we can use different methods than the i3.place method that was generated at the start. We can use i3.placeRelative, which positions components relative to a reference. We can also use i3.join and i3.connectBend to make the connections between the components. We can also use i3.connectManhattan and append this to the specs list. This makes connections at 90-degree angles between the relevant components. So we can export back to Canvas by using toCanvas. So let's run the modified code. And we can see the changes in the schematic. Here we have some new connections we can view. So we can select properties, and we see some parameters now exist. And if we want to view those, we can select show card. In this tutorial, we've seen how to implement a schematic in Canvas. We've looked at how you can import a library and drag and drop the components. We've seen how easily you can align them and view and change the properties and metadata. From there, we eventually generated a code where we simply right-clicked on the schematic and exported a piece of code that we could work with. Please visit our Lucida Academy for many more interesting examples. And if you have any questions, please don't hesitate to contact us at support@lucidaphotonics.com.